So let's talk about limits. Let's see here, this thing right there. So this is a rational function, and it's asking you, what does this function do when x is approaching 4? That's what the limit means. So you approach 4 and then see if you can plug it in. Sometimes you can just straight up just plug it in and you're good. Sometimes you can't. The best thing you should do before you start is to graph this guy. So number 1 here, I'm going to graph it first. Yeah, let's see here. Just realized I'm starving. Let's see here. So f of x is equal to, let's see, x minus 4 over x squared. I already forgot what it was. Minus 5x plus 4. Okay. So if we factor the denominator, it's most likely going to have an issue at 1. You see how it skips 1? It's not defined there. There's an asymptote at x equals to 1. It looks like 4 is fine. There is no issue at 4. So what the limit's wanting you to do is to plug in numbers closer and closer to 4 and then see what those y values are approaching. You see those y values are they're approaching some number, right? As I get closer. When I get there, it appears to be undefined. So it looks like I can't plug it in. If I approach from this side, before it hits undefined, what is that y value approaching? What do you think? From this side, looks like it's 0.3 something, right? So the limit, since the limit is the same on both sides, then that means the limit exists. So for the limit to exist, it needs to be the same from the left side and the right side. So what they're having you do in this homework is approaching numbers closer and closer to 4, because I can't use 4. 4 is undefined, but 3.999 is not undefined. Get closer and closer to 4 from the right side. 4.001 is okay, etc. And notice what the y values are doing, right? They're getting closer and closer to 0.3 something. So all you got to do is plug these numbers into your x values and see what you get. Plug this into the x values and see what you get. And eventually you approach something. That something on both sides here is the limit. That's all limit means. Okay, so yes, so we know.
Sir, could you please do another example?
Yeah, we will in just a moment. We're going to do a bunch of them.
Thank you.
Okay, so the question is asking the limit as x approaches 4, this is what this means, of this function right here. Now, the limit as x approaches 4, let's factor the bottom so you can see the problem. What does this factor into? The denominator, what does it factor into?
X plus 5 and x minus 1.
X looks close. Let's see.
So it's x minus 4 and x minus 1.
Yeah, minus 4, minus 1. So you see how if I plug in 4, there's a problem, right? So that's why they do limits. So the idea of a limit is basically I can't plug in 4. So I get really close to 4, infinitely close. And then I check what's going on. Okay, so I check from the left, I check from the right. So this is the notation. The limit as x approaches 4 from the plus side, that means of some function. Let's call this f right here. Just to stop writing all that. This means find out what the y value is as x approaches 4 from the right. X approaches 4 minus, that symbol means the same thing. I'm gonna put quotes just to say that this is the exact same thing. Copy paste this over here. But from the left. Okay. The limit of a function only exists if the right and left-handed or left, I'll just say left limits, right and left limits are equal to each other. So if I was approaching from the right and I got some number, right, it looks like I'm approaching some number, then I approach from the left and it turns out to be different, then there is no limit. There is only one-sided limits. So right side or positive side and left side, which is the negative side. Okay, so over here, back to the picture, right? As I approach 4, I'm getting closer to 0.3 whatever. I'm sorry, yeah, 0.33383 whatever, 34. From the right side, I'm approaching the same thing. So since it's the same, then the limit exists. And that limit is this, 0.333. Okay, so all you have to do is plug these numbers into the function and write down the solution every single time and then plug these in. And then you'll see that it's approaching something from the right side and the left side. And since they are basically the same, right? Limit exists. Okay. So the idea of limits is you approach something because you can't just straight up plug it in. Okay. Is there any questions on that idea?
Okay, this sounds like a dumb question, but to get the last answer, do you just take all the rest of them and average them out?
I think you could just plug in 0.333. I would just plug in that because it looks like that's what's happening. It might give you a tolerance. So let's see if there's a 0.333. Let's say I put, I don't know, 4. So I don't know if it'd take it or not. Can I submit this? Let's see a submit button. It should, this is round to 4 decimal places. I don't think it's going to be much of a stickler. I say just try to guess a number between these two. You could average them. I think that's a good idea, honestly, but I don't think it's going to mark it wrong if you plug in one or the other. But just try and let me know. But it's a good question. Any other questions on limits? On this one at least. So this is,
Sir,
yes.
could you give an example of, well, I don't think I fully understand the limit only existing if the right and left are equal. Like that part was a little confusing.
Okay, let's find one. I think it's going to be covered more in the next section. Let me double check though. Hold on. One moment. Too many tabs open.
Sir,
Yes.
is there ever going to be like an instance where they're not going to be equal?
Yeah, you'll have strange functions that they're not equal, and you just say, and the limit doesn't exist. You just put D and E. That's it.
Okay.
We'll do one of those as soon as I can find one. I don't know if it's too soon to do it, so I'm hesitating. One second. Well, let's just go ahead and talk about it now. It's fine. We just might have to, we're going to talk about it a bunch of times, this section, next section, etc. But look at this point here. Look at number 10 for your question, Selena. Let's say that number is 1, right? Looks like 1. So you see that the left limit, let's say this whole thing is 1 f of x, some function f of x. And let's suppose that, oh, here it is. The limit as x approaches 1 of f of x is, so let's say we're doing this part right here. The left side is approaching the number 4, right? As I get closer and closer to 1, the y value is going to 4. Do you agree?
Yes, sir.
Right, so the left-handed limit would be 4. The right-handed limit as I approach 1 from the right or the positive is approaching the 1 y value, right? So the right-handed limit is equal to 1, the left-handed limit is equal to 4. Because they are different, it does not exist. Does that make sense? That's the idea.
Yes, sir.
I think I just need to do the homework and figure it out from there.
Okay. Let's see here. So it's going to start off with find limits. So we're doing limits graphically. So the first few problems are just plug in numbers and just, this is one approach. It's like crunching numbers to figure out the limit, right? That's one approach. So you just plug in numbers closer and closer and find out what it is. So 1, 2, and 3 is just the same thing. All these are the same. They're a little annoying because you got to plug them in there. I would say just use a calculator or Desmos or something to make it easier. Make this your f of x and just plug in the numbers. That's what I would do. Let's look at number 5. So this is my function f, and it's asking me what happens when x goes to 2. Well, there's no issue with me plugging in 2. I can just plug it in. What is 3 minus 2 going to be? Right? You see how that's the point, 1. So in this case, you can just straight up plug it in and who cares? But if we think of it in terms of just the definition and the ideas, as I approach 2 from the left side, my y values are going to 1. As I approach 2 from the right side, my y values are going to 1. So since they are equal and the same in both directions, the limit exists. Okay. So as I approach, I get closer and closer to 2. From the right side, my y values are going to 1. That's all you have to do. Okay. Any questions on 5? I mean, there's not much to do here. Just literally plug in the 2 in there. But the concept is what I need you to do, is think about. So does the concept make sense?
So at the, 2, it would be undefined. If we were to graph it,
Well, this is the graph right here.
right?
So as x approaches 2, it goes to 1 and it goes to 1. So since they are the same, the limit is 1. That it exists.
Oh, okay.
But if it was more like that other one, right? Let's say, look at this graph. The number -4, as I approach from the right side, I'm going, the y, well, actually the y value never changes. I'm going to be at 1, right? If I approach from the left side, I'm going to -1. So these limits, the right-handed limit and the left-hand limit, are different. Therefore, the limit does not exist. So straight up, one-sided limits do exist, but in this example, it does not. Okay. Does that make sense?
Yeah.
So all you got to do, so this a little simpler here, x going to -4, all that means is you look at -4 and see what's happening as you approach it from either direction. If they're different, no limit. Let's check this one out. So this is the function that they graphed. We're looking at it, it's all visual, so there's no real calculations here. So
Oh, sir.
Mhm.
I'm sorry. Could you scroll up to number 7 again real quick?
yeah, sure.
So, DNE. Oh God. Why is it that answer again?
Because they're not the same. The value that the y values that I'm approaching from the right side are not equal to the y values that I'm approaching from the left side. As
Okay.
I'm going to -4. So this just tells you where you're going,
Yes.
and you just observe what is the y value doing. What is the y value approaching, or what is it as I get closer to this number? So you check the right side, left side. That's all
Okay.
you're doing.
Thank you.
So what do you guys think about this one? What is the left-handed limit as I go to 0?
Are you really asking?
Yeah, what do you guys think? What is the left-handed limit?
For 1,
Yeah, so from the left side, the function is going to 1. Okay, someone else, from the right side, what is my function going to?
0.
Yeah, 0. So those are 2 different numbers, correct?
Yes.
Therefore, does not exist, right? Is there any questions on that? There's not really much to do other than understand the concept. Any?
yeah. So like on these, we really don't need to look at the equation. We could just look at the graph. Or they
Yeah,
should
you
be-
can always graph them and see what's going on. If the question says to solve it a different method, like analytically, but this entire section is about finding the limits graphically. So we're just looking at the graphs. The first few are punching in numbers, which is whatever, but the rest are just analyzing graphs and figuring out, okay, what is the function doing as I get closer to that number they're asking about. Okay. So like this one, they start off like, you know what, plug in 1 and what happens? Well, if I plug in 1, the only solid dot at 1 is right there at 2, right? Because the rest have holes, so those are not values. So this is a functional value, and then this is a limit. Over here, f of 4 has a hole in it, right? You see how it's not defined there. That's why they put D and E there, because there's a hole. But the limit exists because as I get closer and closer, it's approaching the same place, approaching 2. So it does not exist, but the limit does. The value itself does not exist, but the limit does. Over here, we have the opposite example. The value exists, but the function, the limit doesn't. So just check both sides and then figure out if they're the same. That's all you have to do for limits. Later, they might ask you for just one side or the other, but I don't think they do in this section from what I can tell. Yeah, they don't. But if you want the theory, please watch the videos I posted there. They go in. The theory is very in-depth and complicated, but the actual solving is pretty straightforward. You just look at the graph and see what's happening at this value. Okay. Any other questions on this section? Not much
Can-
else to do.
Can you show us the one with the pies?
Pi, this guy?
Yes, actually, yeah, that one.
Okay. So number 9, it's asking what's happening to pi over 2. So that's this asymptote right there. So as I approach from the left side, it shoots off to infinity because this is an asymptote. So this tangent function just keeps on going forever. Right? It goes and it gets infinitely close to the asymptote, but never actually touches it. Okay. From the right side, though, it's going to negative infinity. It gets infinitely close, but never touches it either. So both directions are going in, both of these sides are going to the opposite directions. So that's why the limit does not exist, because this one's infinity and this one's negative infinity, not the same. Does that make sense?
Yes, sir.
Yeah, just look up in the value and just see what the function is doing. This one you could also graph yourself on Desmos if you want to like zoom in and drag stuff. You could do that too. Number 6. Let's see here. Number 6 is asking for you to find out what's happening at as x approaches 1. So as I'm going, so here's 1, right? Here's the x value. You always look at this. As I get closer and closer to 1, my y values are going to -1 from the right side. From the left side, it's going to -1. So they're going to the same place, right? So that means that the limit is -1 and it exists. They're not different. So most of the time, if it's connected like that, it's going to exist. But I advise you that you just look at it yourself and see what the y values are doing. And if they're going to the same place, then you're good. You would just say -1.
Okay, so basically, like if it's asking for a specific number in the function,
Yeah,
the big explaining this so bad. So in this case, it's giving you the function and the limit's 1. So you just see look at 1 and then see what's on the y value, and that's the answer.
pretty much. Yeah, you're just looking at the function, which they gave you a graph
Mhm.
of,
Myself.
and you're just seeing what's happening as we get closer to the number they asked about. Yeah, you're looking at what's happening to the y values as you approach some specific x that they are asking about. That's all of them. Same thing here. 4, we look at that x value and look at the y's. Look at the y's, right? Over and over again. It's the same thing.
And on that one you did before that, that little dot, those little dots off to the side, they're for something else or just there?
This,
Took us, yeah.
so this is a piecewise function, right? So this function, the parabola has a hole in it here, but it's defined over there for this value. So when x is 1, they're telling you that x is -2. I'm sorry, y is -2. So they're combining two things into one just to make it more complicated. It didn't make no difference for number 6. It made a difference for this one. When they ask you, what is f of 1? Well, that's the dot, right? Because these are not defined. And then the limit was different. So they made it a point to build this function to show you that sometimes plugging in the number and the limit are not equal. That happens. Sometimes they are exactly the same. Like, what's it? This one. Plugging in the number 2 right here was the same as looking at the limit. They were equal. Both are 1. But not here. You see what I'm saying?
Can you go back to 6 for a moment, sir? I'm just writing down the example.
Oh, you're good. They advise you to look at the video so you can see the definition of a limit. But this is the main concept right here. Just look at the y values. Excuse me.
I got it. Thank you, sir.
Okay.
I'm sorry. What video did you say was posted where?
There should be a lecture video for each section. Let me double check though. So what I'd like you to do is watch the video beforehand, and then we'll try to figure out how to do this together. So we don't spend too much time on theory. So if you go scroll down to week 2, you'll see 2.1 and 2.2 videos, and then week 3, 2.3, 2.4. Okay.
What we're going over right now is 2.2, right?
Yeah, that was 2.2. If you look at 2.4, that's when they start singling out one-sided limits. But so that's what I'm saying. We'll talk more about that in a couple of sections.
Where did you say the video was?
Click modules and just scroll down,
Oh, thank you.
and you'll see where it says week 2, week 3.
On the video for 2.2, that's where we find the definition, right?
Yeah, that's what I'm trying to do this semester is you look at the theory and the details on the videos, and then lecture time we're going to spend trying to solve these problems.
All right, sounds good.
Okay.
Okay, so for like 1, 2, and 3, can you, other than Desmos, because that I could never get that to work for me when it comes to exams, can you show us on a calculator?
Yeah, sure.
Because I'm getting something really weird.
Which calculator do you got?
The Inspire.
Oh man. Let me see.
Are we gonna need a graphing calculator?
No.
Oh, okay.
Okay, let's see if we can figure this weird thing out. Okay, first of all, how do I make this brighter? Hmm. There we go.
Is this a calculator similar to the TI-36 Pro and how we do this?
Not at all.
Not at all? Oh, good.
Okay, so is there a way to create a function in here without typing it over and over again? So the one we were, which one are you doing? What is your numbers?
I think I'm doing one.
Is it the same numbers?
Oh no, you do the other one, or can we do it on the other one? The little calculator thing? Because I'm on the graph.
Hold on, I'm confused now. What do you mean? Sorry.
Because I was trying to graph it and I ended up with 2 lines somehow.
On here, right?
No, on the not on the little calculator deal, but on the if you look at the like top. No, not yeah. I don't know what I'm saying anymore.
It's okay. You're talking about, okay, you're talking about that thing up there,
Yeah.
the graph tool. But I gotta enter the equation somewhere. Let's see.
Hit tab.
So right here, I can type it, I think. What was your function?
The x over 4. I mean x minus 4 over x squared minus 5x plus 4.
Let me put parentheses first. So the top part is what? X plus
X
4?
minus 4.
X minus 4, let's see.
I think I wrote that down right.
Minus 4, parentheses, and then the bottom,
X squared minus 5x plus 4.
X squared. Oh, biscuits.
Sorry.
That's okay. X squared plus, what was it again?
Minus 5x
All right.
plus 4.
Okay. Okay, so
See, I don't have that.
no,
No.
man. I don't know what you're using then. Oh, okay. I was thinking in the calculator up here that maybe
Because my
we can,
equation looks exactly like yours.
I think we can enter a function here. Where is? Because you're trying to just plug in the numbers, or you're trying to actually graph it?
Well, I was trying to try to do both, but told you this calculator is like insanely.
Yeah, it's complicated. No.
And if I don't pay attention, one has a blue case, one has a blue back, and one of them's the CAS and one of them's not the CAS.
I mean, I think, I would just use a basic calculator. Don't need anything fancy. Like you can just plug in the numbers here for the values. As far as the graph, you should be able to you might be able to drag it. Let's see. View. Great.
Oh, wait, hold on. I have an X minus the whole thing in front of it. That could be why.
That's probably why. Is your graph not coming out?
It's coming out funky.
Yeah, that's probably what it is. Just put
Oh, hey,
parentheses
look.
on the top. You got it?
Now it looks pretty.
Okay. I'm glad you figured it out, because I don't know what I'm doing with this machine. Okay. Anyway, Ernesto, the videos are in modules. You just scroll down, you'll see in week 2.
Yeah, I found them.
Okay, cool.
The homework's right under it, right?
Yeah, the homework, you have a video, and then homework, then a video, then homework. So, and I'll be also be emailing you or and posting the notes we do in class and the videos we make as well. So you can have two different types of videos.
Sweet.
Okay. Alrighty.
So like all the following weeks, like week 3 and all that, they're closed for a reason, just so we don't go ahead.
No, I just haven't messed with them just yet. I'll open them soon. I've only had enough time to create a few weeks. But yeah, you'll see all the way to week 16 pretty soon. I only have up to week 4, right? So that's all you can see.
I can see the week 3 is just, you can't highlight it. You can highlight the instructional videos, but not the
Oh
other
yeah, they don't open until you do week 2, and then it unlocks. You just got to click through week 2. Week 3 will open. Okay. Okay. Let's go ahead and look at 2.3 then. This one, there would be some work to do is analytically, so it's not a visual thing necessarily. Okay, so start off with number 1. 2.3, right? That's what I said. Find the limit analytically. I think I spelled that wrong. Forgot to spell it. Oh, that was right. Okay, cool. All right. Let me switch over. Example 1. Find the limit. All right. Can you guys see this? I bought a lamp in order to remove the glare, but I don't know if it's darker. Is it okay so far? Oops.
It seems good.
Cool. I'll keep using the light then. So on this guy, it says the limit of x cubed as x approaches -3. You can straight up just take the limit, meaning plug in 3, -3. -3 times -3 is 9, which is positive, times -3 would be -27. That's it. Cool. So the fact that we're able to plug it in means we're done. So the first thing you should do with limits is see if you're able to plug it in. If you can't, you get undefined, or you can tell that it's going to cause problems, then you have to either use the numerical method by plugging in numbers closer and closer to whatever they're talking about, or graph it and see what's happening at this value. Okay. Let's see. So number 1, 2, 3, 4. They all appear to be just plugging in numbers. Nothing much to do there. Number 5, though, changes. The final limit of the function, if it exists. Write a simpler function that agrees with the given function at all but one point, using a graphing utility to confirm your result. So basically you're gonna use algebra to simplify this and then plug in the number. Okay, so example 2, let's find the limit of x squared minus 9 over x plus 3 as x approaches -3. So factor the top. Oh, crap, I forgot to factor the top. Okay, so that'll be x plus 3, x minus 3 over x plus 3. Okay. Notice that this is going to cancel, right? So now I just have x minus 3. Got to write my limit. You need to write the limit notation up until you take the limit. Like once you plug in the number, I no longer write the limit. So I'm going to plug it in just a moment. I'm just going to put it in right here. So that'll be -3 minus 3, which is -6. So the limit, once I did the algebra, became -6. I was not able to plug it in straight up because of this division by 0, right? Plugging in -3 here would cause 0 at the bottom. But once I cancel those terms, I can plug it in there and not have any issues. Okay, if you were to graph the original, you will see as I approach from the right and left, I'm going to -6 anyway. So you could do it graphically, but this section is asking you to do it analytically. Is there any questions on number 1 or 2? Sorry. So right here, this is what they mean by the simpler function. They mean the factored version that canceled. Is that straightforward? So 5, 6, 7 will all be the same. You're just going to factor the top, cancel the bottom, plug in the number 1 in this case. This would be the result after you factor and cancel. This would be the only thing that will be left. The top will be a difference of cubes factorization. This is a difference of squares. This is just quadratic stuff. So this is the same thing over and over. Number 9 is different. This is a little more challenging. But you guys have any questions with these? Does the factoring type make sense? It's not too bad. Okay, let's do number 9 though. That one kind of weird then. Sample 3. Find the limit. As the limit as x approaches 3 of the square root of x plus 6 minus 3 over x minus 3. So for this type, use the conjugate. To cancel these radical. You guys remember what conjugate means?
When you ask us questions like that, do you want us to answer? Or
Yeah.
just-
Why not? Yeah, I'm not gonna force you, but it's better. So conjugate means it's just two pairs that are the same, except that sign in the middle is different, the plus and the minus. So if you look at the top, you have this term and this term, and there's a minus there. So the conjugate of the top would be the same nonsense with the plus. So you will multiply top and bottom by the conjugate. And you always choose the conjugate of the one that has a square root. Okay. So this is an algebra technique to cancel the root. Okay, so that's the conjugate, multiplying by the conjugate. You guys remember what this multiplies into?
That would be a squared minus b.
Yeah, right. This was the difference of squares, right? So that's basically what we're doing. We're forcing a difference of squares, because if you square the one term and the other term, squaring this term will get rid of the square root. Squaring the 3 will not give us 9, but who cares? What matters is I want to get rid of the square root. So this times this, it's going to give me a squared minus b squared. So I'm going to use the formula to save some time and space here. There's the formula. I'm not going to multiply the bottom. I'm just going to leave it there. So you see how the difference of squares helps us, right? So this will become x plus 6 minus 9 over x minus 3 times this garbage. So this 6 minus 9 is -3, right? So This will cancel. Any questions so far on the algebra? Okay. So now I've removed the problem. I can plug in the number and take the limit. So I'm just plugging the number at this point. I no longer have an issue. This will be the square root of 3 plus 6 plus 3. What is that limit? 6.
One over six.
Yeah, 1 over 6. So there's the limit. If you were to have graphed the original, this thing, you would have seen as I approach from the right and left side, as I approach 3, that I'm going to 1, 6. But they asked us to do it this way. Any questions on number 3?
Can you explain why you use the positive sign for the conjugate again?
So it is whatever you have here. So if this one was plus, I would have used minus. You just do the opposite because I need to create this pair in order to get a difference of squares. That's why I chose plus. And whatever I do on top, I have to do to the bottom to maintain balance. And then I get what I wanted, the squares. That was the whole reason.
So did you say at the beginning, did you put a rule on when do we actually plug in the limit?
As soon as you remove the issue. So I couldn't plug it in straight up. I mean, you should always try it, right? But you might be able to see here that plugging in 3 causes a 0, right? So I couldn't. So first I did all this nonsense. And then as soon as that issue canceled right here, where is it there? Then you can plug it in. There was no longer a problem.
All right, can you give me a second to soak up? I want to see if
Mhm.
so let me see if I would have multiplied it by x minus 3 over x minus 3, and give me a second to think what the denominator would have been. Would it still been giving us problems if we plug in a 3?
Oh, you're saying that if you multiply the top and bottom by x minus 3?
Yes, in the original one. I'm trying to think. I guess you'd come out with the same issue if you plug in a 3
Yeah.
again.
You would have 2x minus 3s, so it would still be there, yeah, the issue. the hint here is as soon as you see a square root, think conjugate.
And whether it's in where the square root's in the denominator or numerator.
Yeah, it could be either one. You still do the same thing. As soon as I see it, I think I got to do this. No, let's move on to the sine, cosine stuff. You guys cool on this page?
I am.
Let me know if you miss something. This is a theorem. The limit of sine theta over theta as theta approaches 0 will be equal to 1. There's a proof as to why, but it's really long. So think of this as a formula for now. So if you see this, well, basically, if you see anything with a sine or whatever, any kind of trig function, most likely they're going to want you to get it into this form or force it into this form and then use the property, change it into a 1. Okay. So whatever x is in there, it needs to be down here. Whatever theta is in there, that theta needs to be down there. Doesn't matter, just make them the same. As soon as they're the same, you can do this. Okay. So example, I don't know what number. 4. Example 4. So as the limit x approaches 0, sine x over 3x. Notice how the x and the 3x are not the same, right? That 3 is in my way, because if it was just an x, it would be exactly like this one, right? So what you can do is pull out a third and not worry about it. Then I have sine x over x. So this will go to 1, giving me 1/3 times 1. So that's what you have to do for these types. Number 10, 10, 11, 12. Pretty much all the rest are variations of what I just did, just in more and more difficulty. Higher difficulty here. Any questions on 10?
Could you show us the paper again?
And on that, can we use the term factored out of 1/3?
Yeah, that's totally fine. It's a constant. So if you look at the properties and for limits, you're able to plug factor out numbers. And I'll throw has everyone signed up for Remind already? I'll throw in some formula charts in there soon. do that in just a minute. Threw in some formulas for you guys and remind.
All right. On the one before that, I can't find that one on the homework. That was on 2.3.
Let's see. 2.3, number 10. What does yours look like, the number 10?
Yeah, that one looks like number 10, but on the one before that, when we did the conjugate
What does yours look like?
for number 9, like on the one before that, you said when we did the conjugate, you said that was number 9, but on mine's it doesn't look. Mine's looks x plus 4 minus 3. Oh, they switch them. That's why the numbers are red.
Yeah, the red numbers are just randomly generated. But it's the same process though, same ideas. All right, let's do one more and then we'll stop there because we're a little bit ahead. Which is good. Okay. Example 5 looks a little challenging. We'll do that one and I'll leave the rest to you. And if you have some questions on Wednesday, we can work on it. Okay. So here we want to use the technique again, this theorem. We don't have a sign anywhere. So we got to see if we can use some identities from pre-cal, right? Your favorite section, and see if we can get a sign. So what is sine in terms of as a ratio? Or what is tangent? Sorry, what is tangent?
Isn't it 1 over sine?
You're asking like cosine over sine, or you're talking about sine over cosine? Are you asking us like that, or?
Yeah, like those. What is tangent? Right? You guys remember or no?
Is it cosine over sine?
No, it's close, man. It is sine over cosine.
Yeah.
So you see when you write it, it's going to cancel that other cosine, right? So change it to a ratio. That should be a 3.
So it'll be 1.
These are gone, right? So now I have sine 3 theta over theta. So currently, I cannot apply the rule because the thetas need to be exactly the same. And I have a 3 theta, and this is not a 3 theta. So how would you fix this? How would you force it?
Can we do a 3 over 1?
We have to keep balance. That's I like where your head's at though. But we
Yeah,
gotta,
because the 3 is in between the sine and the theta, so it's not like we can factor it out just like that.
no, yeah, we can't mess with this one. So we're forced to introduce the 3. So, but how do we introduce that 3? So multiply the top and bottom by 3, right? You can always do that. It can't be 3/1 because that would not be balanced. But you could do 3/3, right? You see what I'm saying? So now it's the same. So that this 3 is just in the way, but I had to do it this way. So just pull this 3 out.
Wait, how did you get the 3?
I multiply the top and bottom by 3/3. So from here to here, multiply by 3/3. So that's why I got these two. This one serves no purpose right now, so pulled it out. And now I have what the definition wanted. So this will become 3 times 1, which is 3. Any questions on any of those steps? All right, I guess we'll,
Wait, I'm
Mhm.
sorry, sir. I was trying to figure out how to ask the question.
No, you're good. So
So you put the 3 out in front of the limit symbol?
yes, you can pull it out in front. You can do that for
How?
constants.
Okay,
So any constant can be pulled out in front anytime,
okay,
as long as it's not doesn't have so whatever variable we're dealing with has to stay in here. Here,
okay.
let's see. Let me show you the limit rules. So right here, these are the properties of limit. So this is in the videos. So any constant c can be pulled out in front. If you have a sum and difference of functions, you can separate them and take the limit separately. So if you have a bunch of terms, you can just do each term one by one, if that actually helps you. If you have a product, you can do a limit separate and then multiply those solutions together. Same thing with division and powers. So these are these will be somewhat helpful for the section. All this other stuff, it'll be for chapter 3. So don't worry about this stuff yet. We are here right now. Any other questions?
I guess that first 3 that's in front of the sign, can we look at that as like a no, I was gonna say coefficient because that's what it would look like, but
Yeah, kind
originally
of.
before we did that.
It kind of is, right? But it's just a factor or product, however you want to think about it. I would just say it's like you're factoring a 3 outside and you're dealing with this. So this limit becomes 1 inside the parentheses. So the last few questions are just you doing some algebra or some trig identities to figure out how can I make it look like this, and then make it equal to 1. That'll be the same thing you're trying to try to do. It's just the questions will look different. So yeah, give it a try, and we can do some more of those on Wednesday. I'll help you out. But everyone's able to get to the homework and access the book at this point.
Yes, sir.
Yes, sir.
Yes.
Okay, and were you guys able to see the formula sheet that I threw in there?
Yes, I can.
Okay.
It came across my watch, but I'll have to check my phone.
Cool. I'll throw it in here just in case. Let me find it.
I got a question whenever you get a chance.
Sure, man. What's up?
So when I'm looking at all the properties that you have, that you sent us, the property of limits, no
Yes.
matter when I throw a constant in, I can always put it in front.
Yeah, you can always put it in front.
So even if like on that, on I guess the fourth one down, you have it as a fraction or ratio.
Mhm.
Let's say like on the fourth one down where it says f of x
This one.
over g of x.
Oh, you
On
mean
the
the
properties that you sent us.
yes, the fourth one. Yeah, the division.
Mhm. So if I had a 3 in front of the f, I could put that in front of the limit. And
Sure.
What if I had like 3 in front of the f and 5 in front of the g, then I would just put 3/5 in front of the limit.
Yeah, that would be allowed. That's legit.
Okay.
So any constant can be pulled out from the top, bottom, or all at the same time. You can introduce your own numbers and then pull them out if you want, or like I did here. I introduced 3/3 and I only pulled out one of them because I was trying to rig the problem into being forced this way, to being a 1. You guys have any
Out of
other questions?
curiosity,
Hmm?
what would have happened if we'd have just done 1/3?
You can't because it's not an equation. So if
Oh.
you were to multiply by 1/3, you would have to multiply the other side, which there is no other side. So you have to do 3/3.
Oh, okay.
Yeah, because it's like multiplying it by 1. You don't really change the value of it.
Right, right. So we use the form of 1 because that's the only real tool that we got when we don't have an actual equation. Any other questions?
The only questions I have to do with just me with the orientation module. Some
Hmm.
issues I have, so and I can ask you right now, or I can wait till tomorrow between 9 and 12 sometime.
Yeah, let's do tomorrow because I've been
Okay.
working since 6 a.m. I think it's time. I'm not gonna drop anybody. Don't worry about it. Just make sure we'll figure it out tomorrow morning.
I didn't actually have to do that quiz, did I?
Which quiz?
I was in the orientation module. I was trying to stay awake at work, so I was going through the orientation module, and it made me do a quiz. I was like, okay, because everything about this class says it's an online class, and I was like, what?
Yeah, I put it in there just to what's it called? So you can set up responders for the new students. So if you have your responders set up already, and since you've been here before, don't worry about it. You're good. I know you have your all their end done already. Yeah, you're fine. Let me try to find the quiz. Which quiz were you talking about though? Was it an actual topics or was it just like the orientation stuff? Trying to find it.
I don't know. I did something to.
Yeah, I don't see any actual like. Well, I thought there might have been a pre-calc quiz, but maybe not. Okay.
No.
Like it was just orientation quizzes, right? Nothing, no actual math stuff.
Just the one that where we had to practice, I think being recorded, the lockdown thing or whatever that's called.
Yeah, that's the main one I wanted people to do. Just make sure you installed it and you're good. If you have that done, then you should, and you're able to access your homework. I think you're more than good.
Sir, you said we were gonna go over this again on Wednesday?
Yeah, we'll continue this on Wednesday. If you guys, so I'll give you some time to watch videos, try it out, and then you can bring some questions.
Okay. Are we done for the evening, sir?
Yeah, we're done for the evening.
Okay. Have a good night, sir.
All right,
Good
thank
night.
you. So you too, man. So 2.2 and 2.3 is what we're gonna discuss on Wednesday.
If
Oh,
you
yeah,
have
2.4.
questions, yeah, bring some questions on 2.2, 2.3, and we can work on it together. If you guys are all done and good, then we'll move on.
So it was a netiquette quiz.
Oh, yeah, don't worry about that. It's fine. A lot of it was tailored for online, and we're not online, so
Are we actually going back to class next week?
yeah, 31st, I believe, Monday.
Okay. Because I have a speech class at Northwest Vista and it ends at 8:15.
Oh man,
Oh.
Jeebus.
Well, I tailored my entire schedule to your class, so
Well, thank you, but I'm sorry you're suffering at the moment.
Is there any chance we could stay online?
Well, we'll figure it out. I mean, I'm probably going to record the lectures, but we'll see. Right now, there's too much going on to figure that out.
Okay. Night, sir.
Good night.
night.